Hello guys, in this video I'm gonna actually talk about routing. We are gonna mention some subnetting. As you can see, I prepared a topology. Okay, so we have two routers in here and two switches. So this is LAN 1, local area network 1. Let's say this is a home or office network that is located somewhere in the world, and we have another home or office network. So as you can see, they are on different subnets and they are actually connected with the WAN. So we are emulating the WAN between those two routers right here. As you can see, I'm using also a public IP address also. So as I mentioned, we are going to cover routing. We're going to cover also subnetting. So the first thing that we're going to do is let's figure out some IP addresses or usable IP addresses that we're going to assign to those hosts in here. I just want to introduce subnetting. I can actually configure this multi-layer switch as DHCP, so it would allocate IP addresses automatically. But for the sake of mastering subnetting, I want to actually sharpen your subnetting skills, guys. Okay, so let's do that. So I'm gonna actually, as we did in the class, I'm gonna actually open gedit. I'm not running Windows, as you can see, so I'm running Linux Debian. That's my favorite operating system. So let's actually start with the LAN number 1 here. Okay, so I'm gonna actually, so we have the IP address 10.200.100.0/25. okay, so /25 means that we have 25 bits in the network portion, 25 bits in the network portion, and we have how many bits left? You guessed it, right? How many bits left for the host portion? It's 7 bits left, since each octet is 8 bits, right? So the bit that I'm concerned about, the bit number 25, exists on the 4th octet, right? So 1, 2, 3, 4. I'm gonna write, that's why I'm gonna write this octet here in binary. I'm gonna write a couple of zeros. So 0 in binary is 8 zeros, as you can see here. Okay, and I'm gonna actually, the bit number 25 is right here. This is the bit number 25. So here we have 24, and this bit is number 25. I'm gonna draw a vertical bar. What I'm gonna do here, I'm gonna copy those bits 4 times, like this. There we go, and once more, here we go. So this will be our network, or let's say net 1. Incrementing the last bit after the vertical bar will give us the first IP address. Incrementing all the bits except the last one will give us what? Will give us the last usable IP address. So I'm gonna actually type L last IP for last IP address. Incrementing all the bits after the vertical bar will give us what? Will give us the broadcast. That's how we figure out the broadcast. The first usable address, the broadcast, and the network. So the network will be 192. So we are doing just binary to decimal conversion in here. So actually 10.200.100.0. That's for the our first net. And then the first IP will be 10.200.100.1 all the way to 10.200.100. You guessed it, right? To what? As you can see here, if we convert this binary bits into decimal, we will get how much? It's 126. Okay, 126. You could also figure that out by looking at the magic number. Okay, so the magic number concept, I'm gonna explain it further. So I'm gonna type the bits, I'm gonna type the power of those bits. So we have 8 bits starting from 0, so 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, power of 3 equals 4, 8, 16, 32, 64, 64 in here, and then 128. I'm gonna actually align those numbers to the corresponding bits on the top of them. So there we go. So as you can see here, let's actually align all the bits. Okay, I didn't 128, 64, 32, 16 in here. Gonna actually make those bits, okay, and the corresponding power of 2, and here we go. Okay, that looks much better. Yeah, exactly. So the concept of the magic number, so when you figure out what is the bit that you're concerned about, for example, we are concerned about the bit number 25 because we have 25 bits are for the network portion. So bit number 25 is our concern. We look at the top of this bit right here, we will find 128. So the magic number is 128, okay, minus 2, minus the broadcast and the network itself, the IP that end up with 0, we can't use it, and we cannot use the broadcast, which is 1, okay, .127 in the end. I'm not going to type everything, so .127 is the broadcast, okay. And the magic number also tells us what is next network. So if network 1 here is .0, net number 2 actually will be 10.200.100.128. So the magic number will be our increment. So we all the time gonna be, okay, increment of 128 till we reach, okay, the 255. Okay, so we figure out using subnetting skills what is the first IP, what is the network, first IP, last IP, and the broadcast, and of course /25, okay, in a subnet mask. So for the mask, actually I'm going to type it here. For the mask, let's increment all those bits, okay, 25 bits are incremented. So here we have 8 bits, 8 ones, which is 255 right there. And then we have in the second octet 8 ones, because all 25 bits are incremented, 255. In the third octet, 255. And in the last octet, the fourth octet, we have only 1 bit turned on and the rest are zeros. Okay, so 1 bit turned on, which is 128. That's our subnet mask. Okay. So now let's actually try with me to do the second, okay, the LAN number 2. Let's do some subnetting, but I want you actually to calculate in your head. Try to calculate it in your head, okay? So for this network we have 28 bits for the network portion, and we have how many bits left? We know that an IPv4 is 32 bits. So 28 plus what number will give us 32? it's 4 bits, right? So 4 bits left. So think about putting the vertical bar after the bit number 28. So we're concerned about the last octet as well, okay? So I'm going to write the last octet in binary as I did here, okay? So instead of 25, I'm going to put the vertical bar right here, okay? That's 28 bits, okay? So now I'm going to copy, okay, the same bits, I'm going to copy them. So for the first, all zeros will give us the network. If I will increment the last bit, just the last bit in this network here will give us, okay, the first IP. If we increment everything except last one, will get last IP. And if we increment everything after the vertical bar, will give us the broadcast. Now, okay, for the LAN number 2, here we have LAN number 1. So this is LAN 1, and this is LAN number 2. So for LAN number 2, the IP will be 192.168.100.0. You could actually do it as I did, okay, in gedit, as you can see. You could do that if you cannot calculate in your head yet, okay, but you will get there somehow if you really, okay, do it, okay, a couple of times, and then you will really get the idea. So for the first IP 192.168.100.1, right? And then for the last IP 192.168.100. Okay, since we have a 28, so we have actually all those bits incremented except the last one. So basically it's 8 plus 4 is 12 plus 2 is 14 right there. Okay, so we could also figure this out with the magic number. Okay, so let's figure out with the magic number. So we have 28 bits are all turned on. I mean 28 bits are for the network portion. So look at the bit number 28, the corresponding power of 2, okay? On the top of it we have 16. 16 minus 2, it's 14. So 14 usable IP addresses, and the broadcast will be .15, and the mask will be, I think you guessed that, so 255, 255, 255, and we're concerned about the last octet, and we have 4 bits, okay, turned on. So 4 bits turned on basically will give us 128 plus 64 plus 32 plus 16, which is 240. Okay, that's the mask for the second LAN. Okay, for the third LAN we're going to do the same, or the WAN. Let's use the for the WAN, actually we have 150 50 55 0/30. So the network will be 150 55 0, right? And the magic number now actually will be 4, okay, as you can see. So this one is the corresponding power of 2 is 4 right there. So increment of 4. So if the first IP will be 150.50.5.1, the last one will be 150.50.5.2. Okay, so we have 2 usable IP addresses. We figured out that we can have 4 hosts minus 2 minus the broadcast and the network itself. Okay, network itself. Then we'll get 2 usable IP addresses. .3 is the broadcast, and then for the mask is, okay, let's see, for the mask we have 6 bits. Okay, we have all those bits are turned on, so 255 255 255 in the third octet, and in the last octet we have 6 bits turned on, which is basically 2. Okay, so 255, 255, 255, 252 for the mask. Now we did subnetting, and we learn how to use the magic number. So let's actually apply this to our configuration. So we are going to start from the router 1. Okay, let's actually give it an IP address. As I mentioned, we're going to learn a lot, so let's actually console. As you can see, I'm using GNS3. I'm not using packet tracer. So GNS3, you could actually have a real iOS. This is an emulation program and not simulation program. So what I want to do, I want to actually shrink this window right here so you could see, or you could put it down here. That's much better. Okay. So here we go. So we are going to configure. I can also turn the interfaces on so you could see what interfaces I'm actually configuring here. This is okay, and this is Fast Ethernet 00, and okay, and here we go. Think 00 and 01. Here we go. So yeah, it doesn't matter. So yeah, so let's do that. Let's actually bring the console again. It's right here. So I'm going to go to interface Fast Ethernet 0/0, and then IP address, and then the IP address is 10. Okay, 10.200.100. Let's give it actually .254, right? 254, the last IP address. We could choose either the first or the last, because when we start excluding IP addresses from the DHCP, so we know it's more easier for us to exclude those IP addresses. You could actually choose any IP, okay, to assign to the default gateway. But normally, it's easy to remember also, so you could use either the last or the, okay, we figured out the subnet mask is /120, okay, 128. Okay, and the last IP in the subnet that we calculate, we have /25 is 126. Yeah, that's why we did subnetting earlier. And here we go. No shutdown. Always issue no shutdown to bring the interface up. Fast Ethernet 1/0. Notice that I didn't exit the interface mode and come back to it. I can switch between interfaces using command line. Then IP address, okay, IP address is 150.50.5.1, okay, for this router, and the mask, we figured out this subnet mask, 252, and no shutdown right there. Do show IP interface brief, because I'm in global configuration mode. I can issue show IP interface brief in a privilege mode without do, but I can force it if I'm in global config mode. Okay, so we have configured this router with the interfaces. Okay, so let's actually configure the DHCP on this router. So I'm going to show you also how to configure DHCP. There is a lot to learn in this video, and hopefully I'm not going to talk too much. IP DHCP pool. This is a pool or range pool. Okay, pool name fill out. Okay, I'm going to ask the router what next pool name. Okay, I'm going to name it LAN 1 right there. Okay, LAN 1 question mark. It's two commands in here. Network, what is the network here that we're using? We're using 10.200, okay, .100.0, and the mask of this network. And then default router. What is my default gateway or default router? IP address is the IP address, okay, of this interface here, okay? So that's my default gateway to the outside world. Default router is 10.200.100.126, like this, and then I'm gonna exit, and then IP-CP exclude address, okay, and I mean exclude the last probably 10 IP addresses, the last 5, okay. We could exclude just only the IP addresses assigned, the IP address that we assigned to the router as well. So 10.200.100.126, okay. We could add another exclusion if we want to, and then I'm going to do write mem or copy running config to startup config in privilege mode. Okay, that's it. Let's actually start up those PCs in here. I'm gonna click and start the PC, and I'm gonna click and start those PCs. Let's make sure those PCs, they will get IP addresses. Gonna go to the console of those PCs. So PC1, gonna type IP and then question mark. Okay, so it tells me you wanna auto or use DHCP. I'm gonna IP DHCP right there, and then after a while we'll get an IP. We're gonna do the same for this PC number 2 here. Gonna go to the console. Here we go, off PC2. So PC2 right here. I'm gonna IP DHCP here, right? And then wait a couple of so we have 2. Let's take this one out. So here we go. So can't find server, DHCP server. Okay, PC2 can't find DHCP server. So we did configure the IP addresses, and this interface here, this interface right here, and this one right here. Okay, so it seems that, okay, let's check the switch actually and see why. Okay, show VLAN brief. Okay, show VLAN ambiguous. Let's do show run. Okay, config terminal, and let's do show IP interface brief. Okay, I can see that the interfaces are down that are connected to the PCs, so I'm gonna bring them up. So Ethernet 01 and 02, I can use range, interface range Ethernet 0/02, okay, to 2 here. Okay, and then no shut down. Do show IP interface brief. And the interfaces are up and running. Do write mem, and let's see the PCs if they get an IP address automatically. DHCP and DHCP. Let's see what will happen. So both interfaces are up and running. 3 interfaces are up and running. Okay, at this point everything should be fine. Okay, PC1 can't find DHCP server. Okay, probably. Let me check this guy here. Let's do show IP interface brief right there. Interface VLAN 1. Oh, interface VLAN 1 is not supported. It seems that this router is running. Let's do show version here. Seems that this router is running okay, L3 is running layer 3, and then it's okay, advanced enterprise. Okay, but it didn't allow me to create VLAN, so let's exit. Okay, let's do VLAN. Okay, here we go, and I'm gonna exit. I'm gonna delete this router here. Gonna actually change this to stop, and I'm gonna delete it right there. Delete. Yes. I'm gonna choose a layer 2 router. I mean, it should work because those are layer 3 switches, but they should actually work. So L3 15 2T. Let's actually use one of the layer 2 switches in here. I'm going to delete this one as well. Delete. Yes. Okay, I'm going to choose also a layer 2 switch in here. And then I'm going to connect. So fast Ethernet 00, then fast Ethernet 0, fast Ethernet 1 goes to Ethernet 0, fast Ethernet 2 goes to PC Ethernet 0 right there. And the only interfaces we have fast Ethernet 00, 00, and then 1 to the PC here, right? And let's actually start this switch. As you can see, now we'll get IP addresses basically. So let's console port, not this one, I mean the okay, so we have already opened the console ports, PC escape character. Let's open console as well here. So we have router 1, we have PC 1 trying to connect. I'm gonna stop this one as well, and let's start them again. Start and start. Okay, cool. Console. Here we go. And let's do IP-CP. Exactly. So as you can see, it gets an IP from DHCP. And let's do that for the other PC here. So console, PC number 2, and IP-DHCP. Here we go. This PC will also get an IP address. So let's move to the other side. Let's move to the other side here. So here we go. On the other side, actually, we configured both interfaces in here. We configured the WAN and the LAN interface. So I'm gonna actually connect via console to the router 2. Now I'm gonna actually configure the interfaces. So interface fast Ethernet 0/0, IP address is 192.168.168 here, not 9, 168.100. Let's actually /28. Let's give it to the last IP, which is 14. Let's say we have only 14 hosts on this network. 255.255.255.240 as the mask, and no shut. Exactly. And interface fast Ethernet 1/0 IP address is 150 here, .50.5.2, because the other one is .1, so the mask is 252, and no shut down. Okay, IP-DHCP pool. Notice if we know how to use the command line, the iOS, okay, later on you could actually access any mode from any mode. So I'm gonna access DHCP although I'm under the interface mode, as you can see right here. Okay, so I'm gonna actually name it LAN 2, and then IP-DHCP sorry, I already did it, so I'm gonna for network. Network is 192.168.100.0, and the mask is okay 240 right there, and no shutdown. Sorry, I'm not configuring the interface, configuring DHCP. We need default router. Okay, default router 192.168.100.14. That's my default router. Then exit, and then IP DHCP. Okay, exclude address, and then exclude the address given to the default gateway to the router 92.168.100.14, and you write mem right there. So now I'm gonna start the switch and start the VPS, start the PC3, as you can see. Now let's open the console, connect via console to the PC, and PC3 in here, IP DHCP. Cool. So at this point, all the PCs, they should get an IP address. So PC2 gets an IP, PC1 gets an IP. Routers are connected with IP addresses. PC3 can't find the, okay, let's do it again. I believe we configured the interfaces correctly. So let's go back to the command line, router 2, okay, do show IP interface brief. Both are up and running, so let's check PC3 here. Yeah, exactly. So it gets an IP from DHCP and everything looks fine. The question now, so we talked about subnetting. The question now, can PC1 ping PC2? The answer is, I think you guessed it, the answer is yes. Okay, the answer is yes, because they don't even need default gateway, because they are connected to the same switch. So in a local area network, PC is connected to the same switch. You don't need router for that or any default gateway. Default gateway is to take packets from the local LAN and forward it out, okay, to reach remote networks. Okay, so can PC1 ping PC3? The answer is no, because we didn't actually teach the routers how to reach those networks. For example, the routers, do you know what they are connected to? If I will go here to the router 1, we go to router 1 here, and then issue the do show IP route, okay, to check routing table. Routers by default, do you know the connected interface that are up? As long as the interface is up, okay, they know what they are connected to. So he knows that it's connected to 10.200.100.0/25 in here, okay, and he knows that he's connected to 150.50.5.0/30, as you can see. Okay, so don't confuse the C stands for connected, so this is connected, and this is the actual IP address for local, L for local. This is actually the IP configured on the interface. Okay, so looking at the networks, we have two networks, /25 and /30. That's only the networks that router 1 knows about. He don't know about 192.168.100.0. So we need to teach him how to reach this network statically. So there is static routing. The administrator, you as an administrator, can configure those routing protocol as I will do right here. So IP routing global config, I'm going to tell this router 1 to reach 168, okay, .100.0 with the mask of 255.255.240, please go ahead and forward it via fast Ethernet 1/0. We could also use next hop and the interface. Okay, let's do them both. So IP route, again, I'm going to issue just hit the up arrow on the keyboard, and I'm going to use next hop. Okay, IP address, I'm going to use this IP address right here. Okay, .2. Okay, 150.50.5.5 here, .2 right there, next hop IP address, and then do show IP route. As you can see, we have an S next to in a routing table. If you want to figure out, those actually are all okay, the codes are written here. So local L, C connected, S for static, R for RIP, B for BGP. Those are dynamic routing protocol. This is for later actually advanced CCNA courses. So yeah, so actually we actually teach this router how to reach, okay, this network here. Now the question is, can PC1 ping PC3? The question is no and no. Why is that? Because simply this PC here, okay, can send the ping all the way to PC3. PC3 send the packets to the default gateway, because he compare his IP address to the IP address of destination PC1, figure out that they are not on the same network. He will send it to his default gateway. His default gateway, this guy right here, will check its routing table. Let's say that router 2 has actually a packet from PC3 destined for PC1, right? And he will do this. The router basically literally will do like this. Do show IP route. He will check his routing table. Can I see some 10.200.100.0 in my routing table? And the answer is no. He would say, huh? I'm lost. I don't know about this network. And he will drop the packet. So what we need to do, we need to configure the same routing, and we need to teach him how to reach this network here. Okay, so static route is always two-way. Static route is always two-way. So IP route 10.200.100.0 255.255.255.128 as a mask, and then via fast Ethernet 1/0 and do right now. Now, can PC1 ping PC3? Yes, of course, the ping is going to be successful. Why? Because both routers, they know. Let's check the routing table here. IP route, this router, and as you can see, he will, when the packet reaches router 2 destined for PC1, he will check its routing table and find out that, okay, 10.200.100.0 is directly connected to me via fast Ethernet 1/0 router 2 says. So he will send all the packets, okay, that are destined for this PC via this way. Okay, when this guy reaches, he figure out in the packet that this, okay, is destined for PC2. PC2 is, okay, connected to his network. He will basically send it, okay, to PC1. Okay, and that's how the routing works. Okay, so I was wondering to talk also about ARP, but I think the video is too long. I promise I'm gonna actually make another video just for the ARP protocol. Okay, so I hope this has been informative for you, and I would like to thank you for viewing.